Number 12 says, use Hess's law and the following data to determine the value of delta H reaction for the following reaction. For this reaction. 5 solid carbon plus 6 gaseous hydrogen yields C5H12 liquid. Now, I'm going to call this thing pentane, because that's what it is. Okay. What do we know, and what are we trying to find? We're given these three equations here. I'm not going to read them off. You can see them for yourselves. All of these have little bits and pieces of the overall reaction that we're trying to make. Right? What are we trying to do here? We're trying to use Hess's law and these data to find the delta H reaction. Delta H of reaction. Okay. Now, what does Hess's law say? Well, it pretty much says you can manipulate equations, flip them back and forth, multiply them by certain numbers, and do that same thing to their delta H's. Then add the delta H's up in order to get delta H reaction. Sounds kind of complicated, but it's really not too bad once you've done it a few times. So here we go. We're going to use Hess's law, manipulate these equations to end up with this equation we're trying to make. We're going to try and make this equation. Okay, easiest way to do this is to name these equations. I'll name them number 1, number 2, number 3. Alright, and down here, in order to find delta H reaction, I'm going to do things to number 1, number 2, number 3. Flip them back and forth, multiply them by certain numbers, in order to construct this basic equation. Let's go. I see I have a pentane in equation number 1, and I have a pentane on my product side. Okay. The best way to go about doing these problems is to find what is rare within these equations you're given. Pentane only appears here in number 1, so I'm going to mess with that first. Okay, so I need to flip equation number 1. So I'm going to put a minus to mean flip equation number 1. What I'm doing is I'm making a plan to tell me what to do to my delta H's. I'll worry about delta H's in a minute, but first I got to find out what to do. Flip equation number 1. I now have pentane on the product side. Everything to the right is the product side. Everything to the left of the arrow is the reactant side. What else do I need to do? I need to find 5 carbon somewhere. Okay, I see carbon in equation number 2. It's on the reactant side, which is good. It's on the reactant side up here as well, so I don't need to flip it. So I have a plus sign. But I need 5 carbons, but I only have 1 here. So I'm going to multiply equation number 2 by 5. Alright? And then I am looking for 6 H2s, and I see H2 here as well. This was really nice because H2 only appeared in one equation, carbon only appeared in one equation, and pentane only appeared in one equation. See, I'm not even really concerned about the O2s or the CO2s or the waters. I don't care. I need 6 H2s and I already have 2. So I need to multiply equation 3. I need to multiply equation 3 by 3. Alright. Seems easy enough. I have a plus sign here because I want to keep this equation right where it is. I don't want to flip it because H2 is on the reactant side here in the equation I'm trying to make, and here. Okay, there we go. This is my plan of action. How do I know it works? Well, we have to check it. So here we go. Here's our check. What I'm going to do is I'm going to follow this plan of action. I'm going to perform these actions on each of these equations and make sure I get my equation I'm looking for. So here we go. We're going to fly through this. It says flip equation number 1. Okay, 5 CO2 plus 6 waters yields pentane C5H12 plus 8 O2s. Okay, then to that I'm going to multiply equation number 2 by 5. Multiply equation number 2 by 5. So here we go. 5 carbons plus 5 O2s yields 5 carbon dioxides. Then take equation number 3, multiply by 3. 6 H2s plus 3 O2s yields 6 H2Os. And what I'm going to do is I'm going to add these up. Whatever appears on the reactant side and appears on the product side, I can cancel if they're the same. Like this. I know I have, let's cancel, what's easy? Oh, waters. I have 6 waters on the reactant side up here and 6 waters on the product side over there. So ultimately, no new amount of water was produced or lost or anything like that. So I can just cancel these. Okay, I have 8 oxygens on the reactant side and 8 oxygens on the products. Cancel, cancel. 5 carbon dioxides on the reactant, 5 carbon dioxide on the product. And finally, I check to see what I have left because nothing else can cancel. 5 carbons, 6 hydrogens, 1 pentane. 5 carbons, 6 hydrogens, 1 pentane. Good to go. So now I'm going to use the same equation that I've been using, and I'm going to perform these actions on their delta H's. Take a calculator, and I've already done the calculation, so I'll just show you how to plug it in. Take delta H number 1 and multiply it by a minus. So we got 3505.8 plus 5 delta H number 2's plus 5 delta H number 2's, so minus 393.5, and then plus 3 delta H number 3's, minus 483.5. Alright, make sure your units are all the same, kilojoules, 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 we're good to go. Punch that out, answer is 87.8 kilojoules.